To find the angular momentum of a person on a roller coaster, we're going to look at what we're given. So we're given a mass of 100 kilograms. We're given a linear velocity of 18 meters per second, and we're given a radius of 15 meters around our circle. So angular momentum, traditionally we would think of as like moment of inertia times the angular velocity, but we don't have that information. There's a longer version to solve this problem where you could calculate moment of inertia treating the rider like a particle, and you could calculate the angular velocity from the linear velocity. But we also know that angular momentum is a product of the radius of our loop and our linear momentum. And since we know the mass and the velocity, we can use that to say the angular momentum is the radius and then the product of the mass and the velocity because P equals mv. So L is going to be equal to 15 meters multiplied by 100 kilograms and our 18 meters per second. So I'm using the linear quantities to find angular velocity because I'm including the radius. And so when I do that, I get 27,000, and the units are a little confusing. So it's kilograms times meters squared over seconds. And the way I like to think of that is momentum is kilograms times meters per second. But when we talked about moment of inertia, or we're thinking about this as rotational, we're sort of doing that in a 2D plane. So instead of kilograms times meters per second for momentum, we're doing a meter squared per second times kilograms to make it that angular quantity.